Let's look at the mechanism over here, which is saying predict the product's form and the acidic treatment of the alcohol given below. So products, again, we don't know whether we're going to form one or two products, so we're going to find out as we write the mechanism. And then we know it's an acidic treatment, which means that we need to have H3O plus somewhere. And then we know we are dealing, of course, with the alcohol. Okay, so here are the things. As soon as you know it's an alcohol, okay, and that you're writing an acidic treatment of this one, it means that your reaction is probably going to be E1, and that's like a 99.9% kind of thing. Okay, so it's going to be an E1 mechanism, which means you're doing elimination, which means what? Okay, it means that you're forming alkenes, all right, because that's what you form when you do eliminations, okay, in there. So, and I'm really sorry about my handwriting. It's really fun for me to write this, but in any case, here, let me do this better. Alkene. Okay, so now let's try the mechanism out. Okay, so here we have an alcohol. Alcohols are this OH group. OH groups are terrible leaving groups. Okay, so in order to make them good leaving groups, you need to turn them into a better leaving group. And the best way to turn them into a better leaving group is by protonating them. Okay, so you take an OH and you protonate that. So now you get something like this. And this is an oxonium ion, okay, and now the alcohol is protonated, and now this resembles water, okay, and so this is a good leaving group, and so now we're going to go ahead and remove this leaving group, so minus H2O, and so here's what you do. You can write the arrow coming out, which shows that it's going away. If you don't like that kind of abstract thing, then you can also show this green arrow, okay, so where the electrons are going on oxygen, so that is also something you can show. So whatever you feel like, okay, you go for it, because both the things mean the same thing. So then we go ahead and write out what we get as a result of this water leaving. And once it leaves, I think I have an extra carbon over here, so let me write this again. And we have 1, 2, 3 there. Okay, so once the OH left, now you have this carbocation over here. This carbocation is actually a primary carbocation, which is not stable. Okay, we all know that. The other thing that we have learned about carbocations is as soon as you form a carbocation, you have to see, can I rearrange it? Okay, so as soon as you have a carbocation, remember, tertiary carbocation more stable than secondary, more stable than primary. Okay, so think about rearrangement as soon as you have a carbocation. So that's the important thing usually for E1 mechanisms, or even SN1 sometimes, okay, is that you have to see about rearrangement. So here we don't really have much choice about what we can shift, okay, because the carbon that is next to the carbocation has two methyl groups, and I can shift a methyl. I cannot shift an ethyl group. Okay, so there are only three things you can shift, okay, and we've been talking about this, but I'll write this again. So you can shift a hydrogen, you can shift a methyl, and you can shift a phenyl group. That's it, okay, so you can't shift really much more than that. No ethyl propyl shifting, okay. So all right, here we go. So now we're going to go ahead and shift this methyl group to this carbon over here. So once we do that, then you have this skeleton, okay, that's still there. You still have this methyl group over here. Now since you move this methyl group, the one on the top on the side here, the methyl group comes over here. Okay, so now if the methyl group is on this carbon, now the carbocation has shifted to the other carbon. And we call it a carbocation shift, but I like to call it more like a methyl shift, because you shifted a methyl group. Once you shifted the methyl group, the carbocation automatically shifts. Okay, so if you think about it as a carbocation shift, you will not think that you have to move something else. Okay, so please make sure you kind of say it in the right way, that you're actually shifting a methyl group. Okay, so that way you also know what you're shifting. Okay, so and here try to write that you're shifting a methyl. Okay, so methyl shift, so that way you know what you've done. Okay, as we go on now, We have a carbocation. Now this is a beautiful carbocation. It's tertiary, it's more stable, everything is perfect. Okay, so now what we have to do is we have to think about elimination. So when we think about elimination, we think about alpha beta or the 1,2 elimination. So 1 is or alpha is where the carbon is, the carbocation is, and beta is, or 2 is where the hydrogen is. Okay, so we're looking for the beta hydrogens, and so now we're going to go ahead and draw out our hydrogen. So this hydrogen, we have another hydrogen here. Okay, and then we also have a hydrogen over here. And yeah, I was a little, kind of slick over there. I drew the two hydrogens in the same color because I needed to mention that these two hydrogens are exactly alike, which means that they are exactly the same. If they are exactly the same, it means that if you eliminate them, then you will get the same product. Now, as you get more experience writing all of these things out, you can actually recognize that. But if you're not able to, don't worry about it. Go ahead and write all the products out, and then you can decide, okay, if they're the same or different. All right, and I'll do it for you over here. Okay, I'll write the 3 products, and then we'll see if they're the same or not. Okay, so let's start with the elimination. So we're going to have to do 3 eliminations here, right? Because we have hydrogen number 1, hydrogen number 2, and then we also have hydrogen number 3, okay, over here. So let me go ahead and delete this arrow from here, and then we will draw another one. Okay, so now we'll do 3 things, okay, that are going to happen because we have 3 hydrogens to eliminate. And since we're dealing with an acidic treatment over here, what do you use as your base? So when you have an acidic treatment, you're most welcome to use water, okay, as your base. Don't use anything else. Absolutely do not use any negative thing at all, okay, because if you're working in an acidic environment, the only thing you can have is water. You cannot have anything that is negative, because that negative will react with the positive, and that's it, we're done. Okay, nothing else is going to happen. And by positive, I mean it will react with the H3O plus. So it'll be an acid-base reaction. All right, so you will not get any other elimination. So water, you can always use water wherever you want. Okay, so let's go ahead and do our eliminations for hydrogen number 1 and 2. So here is for hydrogen 1. This goes down here. And so our product is going to be this. Okay, then I'll do the next one. And here we are going to go ahead and, I don't know how to do this, going to have to be a big arrow coming down here, and this goes down here. The electrons are moving, and so now you have this carbon still here and a double bond here. Okay, and then the last one that we have is the purple one, and so here comes this arrow, and here goes the electrons, and so the product is going to be this. Now, here's the thing with alkenes and the products that you get. If you're not able to determine whether these 2 hydrogens are going to be the same or not, and you write all the products out, no problem. Once you get to the final products, okay, over here, now when you're looking at these, you can name them if you want to, or maybe you're able to look at the 2 structures and see, okay, these 2 are alike. And that's something that you learn early on when we do constitutional isomers and all that. So we learn to recognize organic structures, so we don't have to write the name all the time and see which ones are alike. Okay, and so here 1, 2, 3, 4, 5, right? And here 1, 2, 3, 4, 5. So on the second I have a double bond, on the second I have a double bond, third carbon I have a methyl group, third I have a methyl group. So which means that these 2 are alike or same, whatever you want to call that. Okay, and then of course the purple one is going to be different, okay, for us. All right, so I'm going to go ahead and write this as 1, 2, and then 3 over here, depending on the hydrogens we picked out, which now we know that 1, 2 are the same. All right, so 1 or 2, 1 maybe. Okay, this is going to be, of course, the Zaitse's product, because the alkene is more stable. And number 3 is going to be the Hoffman product, because the alkene is less stable, okay, in here. So then, which is my major product? Obviously, it's going to be the side saves. Side saves product is always major, okay, if it ever forms. So how many products did I get in this one? I got only 2 products, okay, because 1 and 2 are the same, okay, so I got only 2 products, which is really a good deal actually, okay, because you don't really want to get many products in there. Okay, so I hope that was clear.